See next one more application here in the Newton's laws of motion. One block is placed on the horizontal surface. Between block and horizontal surface, frictional force negligible. One air pipe, jet air pipe, water coming from the pipe of area of cross section A, water incident on the block. Now we have to find here how much force acting on the block by the water. So from force F is equal to mass into acceleration. F is equal to mass, M is equal to density into volume into acceleration A, which is equal to rho into, so volume we know, area of cross section to length of the pipe into acceleration velocity divided by time, which is equal to, if rearranging this equation, rho into A into B, L divided by T. L by T is velocity, then rho A V into B. So therefore, this is formula created by water on the block. In this equation, so A area of cross section of pipe, B is the velocity of water coming from the pipe. The density is, the rho is the density of water. You know this is constant value. So 1000 meter per density rho is equal to mass by volume. So meter per kg per meter cube. I'm sorry, kg per meter cube. This is the density of water. Next one, elevator case I'm explaining, elevator or lift. So here 4 cases we have. In all these cases, we have to find apparent weight of the person when the person standing inside the lift on a weighing machine. So these different cases are, suppose when the elevator is at rest, elevator moving upward direction with an acceleration A, elevator moving downward direction with an acceleration A. When it is moving uniformly, uniform velocity, if the cable is cut, elevator moving downward direction with acceleration due to gravity. In all these cases, we have to find apparent weight of person. So who is standing inside on elevator. So first case here, when lift at rest, from free body diagram, FBD, free body diagram, just I am drawing like this. So this is the normal force N and weight of person mg. Then N is equal to no upward force acting on the person because elevator is at rest. So therefore N is equal to mg. This N is the apparent weight of the person. N apparent weight means N is apparent weight or normal force acting on the person, which is equal to original weight of the person mg. Next, second one, if the elevator be upward direction with an acceleration A. Now this is same thing only, free body diagram N and mg, and it is moving upward direction with an acceleration A. Now here, upward direction force N is positive, downward direction force mg is negative I'm taking, while elevator moving upward direction. Then net force F net on a person is equal to, it is N minus mg. Then F net nothing but mass into acceleration is equal to N minus mg. If I take this minus mg left side, then normal force N is equal to mg plus ma. Now here, which one we can take on? M we can take on, then g plus apparent weight of person here increasing while lift or elevator moving upward direction. Next, one more case. See, I am taking here. Now this elevator will be downward direction with an acceleration A. See from free body diagram, weight mg at in downward direction, normal force N. It is now moving downward direction with an acceleration A. The same like before, F net mass into acceleration is equal to, now it is mg minus N. So if I take this N value left side, then mg minus m into A. Therefore, N is equal to, similarly here, we can take common M, then it is G minus A. So G minus A means the weight of the person decreasing here. That represented by the weight. Now one more case. If the elevator will be uniform velocity along the downward direction. Uniform velocity means we know acceleration A is equal to 0. From above equation, that apparent weight of person n is equal to m into g minus a value 0. Then apparent weight is equal to mg. So the weighing machine shows original weight of the person when elevator moving uniform speed along the downward direction. Next, one more last in this one. So when the cable is cut, then the elevator moving downward direction with an acceleration a is equal to g. A is equal to g. So then apparent weight n is equal to, so m into g minus a we know. If substituting a is equal to g in this equation, then n is equal to m into g minus g, because a is equal to g. Then g minus is 0, 0 into m, 0. Therefore, apparent weight n is equal to 0. It shows by the weighing machine. So this is the elevator or lift case, different cases. So how the weight of the person change. Next, one more. Suppose this is a horizontal smooth surface. Here two blocks are connecting. This is one block, and here one more block is connecting. These are two blocks connecting by a rope. Mass of this one m1 and mass of this one m2. So this first block of mass m1 pulling by a horizontal force. Suppose this is the midpoint between m1 and m2. This force F opposite to this force, here tension acting along this direction, and here tension acting. So only one rope is connecting between the two blocks of masses m1 and m2. So this tension T is the same. Now the two blocks are moving along the direction of the force acting on the blocks. So here we have to find two values. One is the acceleration of the system of two blocks of masses m1 and m2, and what is the tension developing between the two blocks of masses m1 and m2. So for this one, same concept, resultant force we have to apply on block m1 and block m2. If these two equations adding, we will get acceleration. After that, if substituting a value in any one equation, we will get tension. See, directly I am applying here resultant force on m1 block, because before many examples we discussed like this kind of cases. Now resultant force on m1. So m1 a is equal to, so f minus t, and this is equation 1. And the second one, m2 a is equal to only tension T acting here. This is equation 2. So if adding these two equations here, m1 plus m2 into acceleration A is equal to, so here plus T minus T cancel. So plus T minus T cancel, then only force F is there. Then finally divided by m1 plus m. This is the acceleration of the block. So suppose here one more block connecting, simply acceleration of the system is equal to, so the total force of what is the external, what is the pulling force acting in the block divided by, so sum of the masses of the blocks. Here two blocks are there, that's why m1 plus m2. If one more block adding here, m1 plus m2 plus m3 like. So if this a value substituting in equation 2, we will get tension. Therefore, that tension T is equal to, so m2 into F divided by m1 plus m2. This is the tension developing in the string. Right, next one more application. So based on Newton's third law, that rocket repulsion I'm explaining, or simply rocket motion. Rocket motion. So it works on the principle of Newton's third law, action and reaction base. Suppose initially a rocket at rest like this. So while rocket firing, the gas is moving backward direction, then upthrust given by is exhaust gas velocities on the rocket, then rocket moving upward direction. This is action and reaction. So here, at finally, the velocity of rocket is v. Here, we should find here velocity of rocket v. And suppose here, if m naught is the initial mass of rocket, and with respect to time, the fuel mass burning inside the rocket. So then, at a particular time t second, the mass of rocket is not constant. With respect to time, continuously mass consumption is there. Therefore, to calculating mass consumption, see first formula I'm writing here. So at any instant of time t, that mass of rocket m is equal to initial mass of rocket m naught minus mu into v, where mu is mass consumption, mu is equal to dm divided by v. This is first one. With respect to time, mass relation. Second one, upthrust acting on the rocket. So here, I told already gases moving downward direction, those velocities of gases are called exhaust gas velocities, which is representing with V suffix R. Then upthrust acting due to the exhaust gas velocities on the rocket, that upthrust is equal to upthrust is nothing but force only, that force F is equal to, so minus V or exhaust gas velocities into dm by dt. dm by dt is mass consumption. And now finally, the final velocity of rocket at any instant of time t, we can calculate by using resultant force acting on the rocket. So what is the resultant or net force acting on the rocket? F net is equal to, so this force upthrust acting, upthrust means which is moving upward direction, but mg acting downward direction. Then it is Vr into dm by dt minus, but gravitational weight acting on the rocket downward direction, which is mg. Then F net is mass into acceleration is equal to V suffix R into dm by dt, m value that side, that acceleration A is equal to Vr into 1 by m into dm by dt minus g. But acceleration A is equal to, rate of change of velocity, which is dv by dt. dv by dt 1 by m into dm divided by dt minus g. If I take this dt that side, then the velocity dv is equal to, so Vr 1 by m into dm, dt cancel, minus g into dt. So therefore, this equation, if integrating, we will get final equation that velocity v is equal to u minus gt plus vr log se m naught by m. This is the finally velocity of rocket at any instant of